Hi, everyone. My name is Rohini. I work with the Climate and Environment Data Unit with UNICEF. I'm curious to see how many of you have heard or follow the work UNICEF does. It's the UN agencies for children, and we are present in almost 192 countries. So the motto that I've been living with is everything happens somewhere, right? And the question we all try to answer is, but where? So I wish my animation worked, but since it didn't, let me walk you through. It's 2024, and we probably would imagine every part of the world is mapped by now. So just last year, I was in a sub-office of the World Food Program in Republic of Congo. The first screenshot you see is from my phone, from Google Maps. The second one is from Big Maps. If they are not mapped, are they still there? Are the villages there? How many children are living there? Where are they? How are they accessing their essential services? How can we access them? So we started a massive open source project, joining a lot of people and very high resolution Earth observation data to start mapping people where they are. So that's the first fundamental question that we try to answer with Earth observations. And the second thing that happens is everybody is at risk, irrespective of where somebody is living. There is nowhere on this planet we can point and say, oh, there is no risk at that point. And especially with the changing climate, we are seeing the risks of children more and more to multiple different hazards. So now the question is, for the whole world, for all the 2.4 billion children, can we estimate the probability of what hazard they would face and how vulnerable they are to the hazard? And that's exactly what we started doing. Just 10, 15 years ago, it would be really hard to do a global model for every single climate and environmental hazards. But we're, thanks to sophisticated Earth observation technology, as well as a lot of powerful computing resources we have, we're able to do that. Starting from heat waves, we start to look at every single one of the climate hazards and see what the exposure of children looks like for each one of them. This is an example of riverine floods. Over 300 million children are exposed to riverine floods, and we have over 1 billion children exposed to droughts. Cyclones, it's the same. Over 400 million children we found are exposed to cyclones all over the world. And malaria, it's also the same. And with air pollution, recently we have a lot of different satellites that are adding to the way we can monitor pollution, because as you can imagine, it's one of the hazards that affect children the most, especially they are vulnerable when they are growing under the 5 years of age. Now we are able to even find the sources of pollution, not just industrial or agricultural forest fire related pollutions. So thanks to powerful data that we are able to process at near real time, we are able to inform a lot of different policies, both within UNICEF as well as with the host governments that we work across the world. We put them all together and try to understand, okay, we have multiple different problems we are facing. There are planetary challenges all around us. How do we prioritize? Where do we start? And that's where the Children Climate Risk Index comes into place. We try to prioritize at different national, subnational levels, trying to understand where are the areas exactly where we need to start programming, planning, preparing, and trying to understand how we can reduce the vulnerability of children in these different areas. But it's not just for risk analysis alone, right? You also have a lot of response-related applications of Earth observations. This is a recent example of last year from Gaza. Right after any major war or disasters in general, the first question is, how many children are impacted? How many schools or essential facilities around where they live are impacted that could affect their well-being? And we need to continuously monitor and do this as the conflict or the disaster progresses. And Earth observation has been central for us to be able to reach areas where we can't reach, obviously, in situ observations. And this is an example from Ukraine. For the last couple of years, we were able to monitor different aspects of the conflict itself on how it impacts children. So just to summarize, over the hazard timeline, from planning all the way through preparedness, early warning response programming, we extensively use a lot of different Earth observation data sets. And progressively in the last 20 years or so, we have seen the increasing adoption of these data sets and increasing awareness of these data sets as well. In the beginning, it was very hard to convince people to rely on this. And now we have switched the table where a lot of people from different country offices reach out to us and ask, oh, is there any data that you would be able to provide us to help us understand what the situation on the ground looks like? So that's a good thing. In the last 10 years, we have seen a lot of trust towards Earth observation data built. But if I have to summarize what I expect from the applications or EO and the state of the EO in 2025, the first thing I hope that I see is that more of the world to be mapped. We are getting there. We are slowly getting there. Just before the presentation, I quickly checked, and we still don't have the area in the Republic of Congo mapped in Google or Bing Maps just yet. But with advanced technology, with more automated processing, with advanced computing resources, perhaps we would be able to do more of that. And another bigger shift that we see is there are more accurate hazard models that are available now, especially for the climate front. From floods, which has been modeled quite well, we also are getting more and more projections into the future to help us understand the different scenarios of carbon emissions, as we hope, how 2050 could look like, how 2100 could look like. And that has become a very powerful tool for us to advocate for children who will face the worst of climate change in the next 50, 100 years to come. I also expect that there will be a lot more sophisticated and automated impact analysis. Watching all the other presentations, I could already see how much more efforts are being done in the industry that we would be able to use and adapt. And as everybody is talking about AI, I'm hopeful, but I'm not sure how operational it would be in 2025 for Earth observations. But in the near future, I would expect I would be able to come into a platform and start asking questions in natural language and expect some maps and information to be provided at scale. So overall, I think without Earth observation, it would be really hard for us to be able to plan or program or have an evidence-based decision-making from our end. So I hope we can continue improving and collaborate with many of you as we go. Thank you.